Okay, so first, I've seen some of your questions on the chat, and if you're asking questions about the content, I'll answer that later, not right this moment. Most of your parents should have gotten an email from me on Monday, and that should have let you know some places to go and given you some information. Most of you probably found out about this Zoom meeting because you're on the Remind. Almost all of you are on it. There's, I think, 4 people who are not. Please tell them about it. I don't think Abhinesh is not on the meeting, on the Remind. David Cho, I don't think is on the Remind. Logan Martinez, I don't think you're on the Remind. I think you joined the AB one. And Riley Stanbury is not on the Remind. So if you could please tell them, that would be helpful for them. That's
Mr.
where.
Hunter?
Yeah.
I don't have a phone, so how should I receive information?
Oh, okay. Well then, most of the stuff that I put on there is also going to continually be going on the calendar or my class website at the front page of the website or just on the BC page. So you can check there as well.
What?
Okay, so a few things in the email that I sent your parents. I'm going to change the screen real quick. Let's look here. So if we go to my class website real quick, this is what it looks like if you just pull there. I added a few things. The Khan Academy join code. Edgenuity, which is the online program the district wants us to use, does not have Calculus BC. Because Edgenuity does not have Calculus BC, we need to use something else. So, which is why we will be utilizing Khan Academy way more than in the past. So, you do need to join this class code for Khan Academy. Some of Khan Academy's, its teaching is still really good, but some of its practice problems are not as rigorous as it should be in these units, which is why I will also use the usual packets that we have in the past. I sent out a link to the packet in the Remind. The link to the packet is also on the calendar. So if you check the calendar, you can get the blank packet as well as keyed pack, as well as the keyed sections on some of the individual days. If you're not on the Remind yet, other than Logan, this is the Remind code right here. And then let's go here. Okay. So this is the email that I sent to most parents, or at least an updated version. Let me also say, y'all probably miss seeing each other and miss school. I do as well. This is a crazy time, and I'm still figuring out what we're doing as well. And it really sucks that you're missing more than a fourth of your senior year, possibly. But we're gonna do the best we can. I will continue to post lots of stuff on the calendar. This right here is the link to the notes and homework packet. It's also, the link's also on the calendar. As I said, the online system school district wants us to use isn't there. We're not going to use Delta Math. I shouldn't have included that, but you got the Khan Academy link to the class and the Remind. So, and then my plan right now is to have Zoom classes on Monday, Wednesdays, and Fridays. We obviously didn't have one this past Monday. We'll have another one on Friday, then Monday, Wednesday, Friday of next week. I'm not looking past Easter right now because I currently have no idea whether we will be in school or not past Easter yet. District has said that they will reconvene April 6th to make a decision about the rest of the school year. So I'm to figure out what will happen for the rest of the school year that week. Okay, and on Khan Academy, I can track and see what you're doing with the assignments that I've already posted on there. But let me stress, I've been told nothing in this time where we are not at school is for a Langham Creek school grade. Nothing is for a grade. I mean, some of these exercises you do on Khan Academy, they'll let you redo it anyways. The purpose of the Khan Academy is to have better problems and more instruction to be prepared for the AP exam, and so that I have a place to see if you're actually trying and participating, but none of it is for a grade. But if you don't do it, you won't be prepared for the AP exam, and all but one of you are taking it. What else? Oh, Zeus asked, how do we join? So if I go back and show you again. So on the class website, if you just click BC, it takes you here. The easiest way to join is just to click this link. Just click this link.
Oh, I should have done that.
It takes you here. It's not going to ask if I want to join because it'll be confused because I'm the owner of the class. But it'll take you to a place and then ask you if you want to join. That's the easiest and quickest way to do that. Another way is that on the calendar, right here on March 16th on the calendar, I also have that link as well. And you just click there, it'll take you to the same spot, but there's two different links. That's the easiest and quickest way to join it. Or if you log into your own join code, if you log in to your own account at Khan Academy, you can click to join a class. There's an option to join a class, and then that will be the last few digits. Like all this last section of the link, SKZ, C9KRJ, those letters and numbers, that is the join code if you just click to join the class. Okay, Sean asked, should we be here? Oh, well, on Monday, Wednesday, Friday, when we do these Zoom lessons, unless other people have issues with this, with the time, my plan was just to continue to do 1:30 p.m. Monday, Wednesday, and Friday. So we have 1:30 today. If another time works better for everybody, we could do that, but that is unlikely to get a time that works best for everybody. Keep in mind, I said earlier that I will be recording these, so if you can't be there, like Adam told me that he has to work today and may not be able to join, since it's recorded, I will then post it also to the calendar. And so if you can't be there at the 1:30 Monday, Wednesday, or Friday, then you can watch the video later at the calendar. And then I think someone on the chat asked about printing the packet. If you have the capability, awesome. If you don't, you can use, if you probably all have access to look at it. So my just suggestion is in a notebook, whenever I go over problems or when you want to do the homework problems, just do it in a notebook. But the problems you'll just look at the computer to see to be able to access the file. Jessica asked if I can create a Google Classroom. I will, yes, I wanted to, but I wanted to go ahead and get busy with, since I didn't already have one being used, I wasn't going to try to do that like by today or this week. So by next Monday, I will have a Google Classroom connected to the calendar and where I will post other stuff like that as well. But didn't super need it till now. So I have a lot of work to do and all of that kind of stuff. Any other questions? I'll unmute y'all. So before we get into any lesson, any other questions? It's like today and in the other times we do these, I'm going to work through the lesson sections from the packets that we would have done, and I completely understand that you don't have the packet physically, but you can view the packet on your either phone or computer and just work out the problems as I work them out in a notebook. Oh, some huge stuff I forgot. Changes to the AP exam and AP update about this. They have said that the AP exam will now be online through the AP Classroom. Whether we are back at school or not, because that's just across the board for College Board, the AP exam will now be online through AP Classroom. It will also only be free response questions now, and only 45 minutes. So this year's AP exam will now not have multiple choice, only be free response, only Logan, I don't think that will work. But it probably, I don't know. It probably won't let you open up another browser while you're in it. Lauren asked if there would be a calculator. That has not been confirmed yet, whether it would be a calculator only or not calculator. The only things that I know, a few things I know for sure, is that the exam will be online through AP Classroom. They haven't said what dates yet. They said that there will be 2 different day options for when it will be. And it will be all free response, 45 minutes. I don't know the answer to that, Riley. Their goal is for it to be the kind of free response questions that you can't just straight look up unless you're looking up how to do something, which would then waste time. So it's not going to be kind of questions that you could just search into Google or Wolfram Alpha. It would be, or if you did, the only way that would help would be to look up how to do something, which would then be wasting time. Lauren, I don't know the answer to that question. Don't fully know how it's going to work yet. I will find out a lot more information when they give another update on April 3rd. There will be another update on April 3rd. What else? Starting today, and then every weekday for like the next month at least, College Board had already, before this pandemic, planned on doing AP review sessions live on YouTube that then you could just watch the video later or watch it live. of calculus teachers who make tons of resources for everybody. And I have the link to that YouTube channel also on the calendar. There's a few topics that College Board is not going to include on the AP exam because they are not confident that everyone would have taught it and want to be equitable about that. Although there's some topics most people probably haven't taught that will still be on it, because without those it wouldn't be Calc PC. And so Unit 9, which we just finished before spring break, is now not on the exam. And about a third of Unit 10, which is what we were going to start after spring break, is now not on the exam. So we still have at least half of Unit 10 that we have to cover right now, sequences and series. But a third of Unit 10 is not on the exam, and Unit 9 of parametric, polar, and vector is not on the exam. And then starting next week, the YouTube review sessions that they're going to do, they're from really good calculus teachers. Some of the person who made the circuits we usually use, and some of the other materials that I've used, those people are doing the calculus review sessions. We will still have some classes, as I said, Monday, Wednesday, Friday on here. Our next one, just to guess, is there going to be a class this Friday, or is it starting next week? I will do one this Friday on sections 17 and 18. Although some of that material most of this material is also on the Khan Academy, but I wanted to still use some of these packets because it has better, more rigorous problems. I will know a lot more information about the AP exam again after April 3rd. From the same guy who makes our notes and homework, that person has made a new practice exam specific to this year that is adjusted and only for response questions. And so we will use that at some point. Noel in the chat asked if we were still going to do after the practice exam at some point. So essentially, yes, at some point we will do a practice AP exam, but it will be an edited one. There's no point in doing the multiple choice part now. And then once we're done going over any questions you have, I do want to get to Unit 16, but if you have any questions about what the rest of the semester will look like for the next few weeks, I want to do that first. So are there any other questions?
So like, can we just skip over all the parts of Unit 10 that we don't need? Or like, is there still some stuff that we should learn just to help understand it?
So there are some sections of Unit 10 that are not, the AP has said are not tested, but yeah. I will still go over them so that we can understand some of the things they said will be tested. And then, but then there's some sections of Unit 10 that are just completely unnecessary, which we will not do.
Makes sense.
Because I don't want to waste your time and my time, especially in this weird situation. And so parts that aren't necessary for what is tested, we will not go over. Any other questions? Zeus asked, how long will the Zoom sessions be? I don't know yet. Ideally, not too terribly long. I don't want to go over absolutely every example on these. I will be combining some of the topics so that we don't have to do it every single day. But probably 55 minutes like class. I mean, today may be a little longer because we spent some of this time going over just a general view of the rest of the semester, though. Any other questions? Okay, well, again, I'm going to post the video later online. Right now, we'll get started on Unit 16. And whether you have the physical copy or not, I would suggest you writing down like we were actually in class. So I'm going to change my screen to be my hover cam so you can see what I am writing. So let's get out a notebook and begin. I think some of you are unmuted, some of you are muted. I think I'll ask questions, some questions as if it's actual class going on. So let's begin. So Unit 16 is, well, all of Unit 10 is on sequences and series. And when we start doing series, it's just summing up a sequence. We got to understand what sequences are first. So you've worked with sequences before in Algebra 2 and Pre-Cal, and probably possibly before that as well. It's just for, you have some term, then you got another term, another term, another term. In a sequence, the sequence is named usually by some letter, like the sequence is A sub n sequence, where n stands for the whatever term number it is in the sequence. So whatever subscript they have there, that's the term number in the sequence. And so this is just representing the A sub n sequence. So the entire sequence would be noted like that. Sequences will be shown to you in possibly 3 different ways. Explicitly, an explicit sequence are examples like this, where they give you a formula for any nth term. That's an explicit, how it would be given to you explicitly. Recursively means that they are, a recursive sequence is like example 2. So explicit sequences are example 1, and giving you the first few terms, that's example 3. So a recursive sequence is when they give you what the first term is, then they tell you a formula to get the next term. It gives you a formula to get the next term. So instead of just a formula to get any generic term, it's giving a formula to get just whatever the next term is based on the previous term. And I say based on the previous term because notice they have A sub n minus 1. So A sub n, your next term, is based on whatever A sub n minus 1 is. So A sub n minus 1 is referring to the previous term. And then giving you a sequence by giving you the first few terms is what they have in example 3, where they wrote out some of the terms. And if they do that, then they're wanting to know what is the formula. So they're essentially, that's just going backwards, and they want the explicit form of the sequence if you have it like in example 3. So let's do a few of these real quick. So like letter A here, they just want us to write some of the first few terms. We'll just write the first 4 terms, then do a dot, dot, dot type thing. So this sequence, the first term, well, we're always going to start the sequence at 0. No, we're going to start the sequence at 1. We're starting the sequence at 1. The nth term is given by plugging in. We're starting at 1. All positive integers. Unless told otherwise, it starts at 1. So we start plugging in at 1. Well, -1 to the first power is just -1. So 4 plus -1, that's 3. Then plugging in 2 to n. -1 to the second power, that's +1 plus 4, 5. Then that'd be a -1 again, so 3, then 5, dot, dot, dot. And that's what the sequence will look like, and that one just oscillates forever. On this second one, again, we're just going to plug in start by plugging in once, then plug in 2, and so on. Okay, so if we plug in the 1 to here, we have 3 over what? 2. And then if we plug in 2, 3 times 2 is 6 over 2 plus 3. 2 plus 1. So 6 over 3. Or just 2. Could just write 2. And then plugging in 3, that'd be 9 on top and 4 on bottom. Then plugging in 4, that'd be 12 on top and 5 on bottom. Okay, now on this one, plug in 1 first. 1 squared minus 1, that's 0. And then plugging in 2. 2 squared minus 1 is 1. And 2 to the second power. Wait. 2 squared, no. 2 squared is 4 minus 1 is 3 on top. And 2 squared minus 1 is also 3 on bottom. So we could have a 1 there, 3 over 3. And then plug in 3. 3 squared minus 1, that is 8. And then 2 to the third power is 8, then minus 1. So then that's 2 sevenths there. 8 sevenths. And then plugging in 4. 4 squared 16 minus 1, so 15. And 2 to the fourth is 16 minus 1, also 15. So we could just have 1 there again. Number 2 is again asking us for what are the next terms in the sequence. But this time they gave it to us recursively. So they told us what the first term is. Again, we'll write the first 4 terms. So we already know what the first term is. It's going to be 3. This tells us a sub n is 2 times a sub n minus 1. A sub n minus 1 represents the previous term. Then we subtract 1. So 2 times the previous term minus 1. So 2 times 3 minus 1, that gives us 5. Then we just do that again. 2 times the previous term minus 1. So 9. Then 2 times 9 minus 1, 17. Okay, then this one. We know the first term is negative 1. The next term. So notice they named this sequence B. It doesn't matter what letter they name the sequence. And then the subscript represents which term it is. So for the nth term, so now we're going to do the second term. We take the previous term, square it, then add 1. So negative 1 squared is 1, plus 1 is 2. And now the third term. Take the previous term, square it. So 4 plus 1, 5. And then 26. And then for C, we know the first term is 22. Next term, we take the previous term, add 2, and then divide by 2. 22 plus 2 is 24 divided by 2, 12. And then we do that again. This one's going to be even smaller. So now we do that again. Take the previous term, so 12 plus 2, 14 divided by 2, 7. And then it'll be 9 halves. Okay. On number 3. Number 3, instead of giving us some formula or way of figuring out what the next terms are, they gave us the terms and we are asked to come up with the explicit formula. As it says here, usually on the AP, then if you have to do this, it's only going to be obvious. It won't be extremely difficult to do one like this. So, and they will probably not want the recursive way. Well, the recursive way is usually the easier way to come up with the formula. So for 3A, we want to come up with a generic formula that would give us the explicit formula for any nth term. So how do we get some nth term for A? Well, we're starting at 4, then we go to 10, then 16, then 22, and so on. we want something such that if we plug in 1, we're going to get 4. And if we plug in 2, we're going to get 10, and so on. Well, is this going up or multiplying by some consistent amount over and over?
Adding
What is it adding each time?
6.
It's adding 6 each time. Well, if you're adding 6 each time, that's essentially a linear function. So we're adding 6 each time, and if we're adding 6 each time, is 6n good enough? If I plug in 1, that first term should be 6 if it's only 6n. So we're going to subtract 2 from that. 6n minus 2, does that work here? If we plug in 1, we do get 4. If we plug in 2, we get 10. If we plug in 3, we get 16. Okay, awesome. So notice we were adding 6 each time. We were adding 6 each time. And if you're adding the same thing over and over again, that's linear. So your expression would end up being linear. If you're multiplying the same thing over and over, that's exponential or geometric. And it would look like something to a power, whatever you're multiplying each time. Let's see what's happening on B. So on B, we have -1, then 4, -9, 16, and so on. If we ignore the 2 negatives, all 4 of these terms are what? Y'all can unmute and talk, can't you?
They're squares.
Yeah, they're all perfect squares. 1, 4, 9, 16. The next one's probably going to be what?
25.
Yeah, well, it'll probably be a -25. Because notice every other one's negative too. So they are all perfect squares. And we are starting with 1. So we will have n squared in there. But anytime we have any sequences that change sign over and over again, if they change sign over and over again, then that will be -1 to the nth power. Anytime you have that scenario. If your sequence is going back and forth from negative to positive, then that's -1 to a power. Because that's what's going to happen if we take -1 to a power. -1 to the first power is just -1. -1 to the second power, then we square, so it's +1. Then to any other odd power, we'll be back to -1. Any other even power, we'll be back to positive. So if it didn't start off negative, we could write n+1 here, or n-1 here, so that it would be negative on all the even powers. And so this was problem B, so I'll call that B sub n sequence. Okay, the next one, C. So on C, we are again going negative, positive, negative, positive. It would probably go negative, positive again. So I know already that we're going to have a -1 to the nth power here. But something else is also going to happen inside here. We have to figure out what is causing these numbers. We do 1, then 2, then 6, then 24. What is producing those numbers?
Is it factorial?
Yes, very good. Yes, it is factorial. Because 1 factorial is just 1. Factorial, the exclamation point. N factorial. Anytime you do a factorial, that is multiplying that number by every number below it. So 1 factorial is just 1. 2 factorial means 2 times 1. Okay, awesome. 2. 3 factorial means 3 times 2 times 1, which would give you 6. 4 factorial would mean 4 times 3 times 2 times 1, which would give you 24. So yeah, it's factorial. Okay, I'll let those 3 be your own practice on your own time. Let's now go to the next page. And again, the blank copy of this entire packet, classwork and homework, is on the main BC page on my website and the calendar. So, on the next page. This section 4, it again gives us some terms and wants to come up with a formula, but they're asking for it a different way now. They're asking for the recursive rule. Oops, you can't. Now you can see it. The recursive rule for it means that we state whatever the first term is, and then we state our rule of how to get the next term based on the previous term. So that means we say what a sub 1 is. Well, here that would be 1. And then we give a rule for a sub n that uses the previous term. So how do we get 2 based on the first term? Or how do we get 4 based on the second term? Or how do we get 8 based on the third term, which is 4, and so on. So what is it doing each time to go to the next term?
Multiply by 2.
Yeah, it's just multiplying by 2. So we're just going to have 2 times a sub n minus 1, where a sub n minus 1 represents the previous term. And then on b, we again state what the first term is. B sub 1 is just 1. And then b sub n, we come up with a formula that would give us the next term based on the previous term. So using the previous term, how could we get 2? Or using 4, how could we get, using 2, how could we get 4? Or using 4, how could we get 7, and so on?
You would add n
Yes,
to the
we're
previous
adding
term.
in, but more specifically, we're adding n minus 1. We're adding n minus 1. And I say n minus 1 and not n because if we look at 7, we want to figure out what would we do before. I'm choosing 7, the last one, so that we have a bigger number to deal with. The 4, it'll make a little more sense to not use 1. So we want to know what would we do with the 4 to get the 7. Well, 7 adds, like this is n sub 1, 2, 3, and then 4. So to get the 7, it takes the previous number 4 and adds that n value, which is n minus 1. We want something that's going to give me the fourth term of 7. So we take the third term, a sub n minus 1, because 7 equals 4 plus 3. That 3 is the previous n. So a sub n minus 1 means, or not a, should use b. B sub n minus 1 is the previous term in the sequence. Then we're going to add n minus 1, the term number, like whatever term it was previously in the sequence. You won't have to come up with recursive formulas very often. It's more likely you might have to use it to come up with the terms. Yeah. And then we'll skip C for now. Right now, we're going to talk about what it means to converge or diverge. We've used these terms before when we did improper integrals. When we did improper integrals, we talked about converge and diverge as in the improper integral, it converged if it actually approached some limiting value for the area under that curve when we went to infinity or when we went to a like some discontinuity point. And we said it diverged if it just continued adding area forever. And it's going to be that same idea. If it continues forever and doesn't actually approach something, then that will be diverging. If it actually approaches some limiting value, then it will be said to converge. So it converges if the terms in the sequence approach some limiting value. That's going to be the definition of converge here and in series as well. We'll talk about, that's going to be the main idea of when we do series, whether it converges or diverges. And then it diverges if it gets infinitely big or oscillates forever such that it does not approach some limiting value. Okay. And then some of them just keep getting bigger forever and ever. If they have some vertical limit, like if you were to refer to it as a function, if there's some vertical limit to your function, or some lower limit to your function as it goes off to positive infinity, then it will most likely converge. It's like on this one in this graph, no, that one in the graph, that's looking at the 2 sub n. But if you have the sequence square root of n, you have 1, then square root of 2, square root of 3, 2, square root of 5, and so on, that's going to diverge because limit as n approaches infinity, square root of n approaches infinity. It just keeps getting bigger forever. So it would have to approach some actual value as n goes to infinity for it to converge. So if we look at 5, well, we already saw this sequence earlier. This is the one from number 1 that went 3, 5, 3, 5, and so on forever. So would this one converge or diverge? This one will diverge because all it does is it oscillates forever. To converge, it has to, the terms in the sequence have to approach some limiting value. And this one does not. It's just 3, 5, 3, 5 forever. It doesn't approach. We can't say it's approaching 3 or 5 because the very next term is going to be completely opposite. This one, we already saw one like it on the front, but we don't really need to look at the sequence. We can look at this like, I'm going to change colors. Should be doing that more often. We can take the limit of this because we want to know what is the terms in this sequence going to approach as n goes to infinity. So that'd be the limit as n approaches infinity of 3n over n plus 1. Well, evaluating this, we could use L'Hopital or just think in behavior rules. What is this going to approach as n goes to infinity based on our n behavior rules?
Is it 3?
3.
Yeah, it would be 3. So since it does approach some actual numerical limiting value that is finite, it is convergent. It converges. Converges. And then on C. On C again, we're going to take the limit. So the limit as n approaches infinity of n squared minus 1 over 2 to the n minus 1. Okay. We could just think top heavy or bottom heavy. We could just think about whether this, based on the n squared minus 1 and the 2 to the n minus 1, would it be top heavy or bottom heavy, and so where would it be approaching because of that? Or this one can be done using L'Hopital's rule. So you can use L'Hopital's rule here, but just intuitively, would it be top heavy or bottom heavy? On the top, we only have a polynomial of power 2, but on the bottom, we have an exponential. Which one's going to grow faster?
Bottom.
Yeah, the bottom's going to grow faster. And if the bottom grows faster and it's bottom heavy, then that is approaching 0, which is a finite numerical value. So it does have a limit. So this one also converges. Okay, then some quick vocab words about this, and then we will be done. So a monotonic sequence is a sequence that either is not increasing forever or is not decreasing forever, which means that it either is always going up or is always going down. And my handwriting, I haven't written in like 3 weeks. Okay, so it's either always going up or always going down. And we already, this is the same one we've seen multiple times, 3, 5, 3, 5. Is that one monotonic? Definitely not, because it's just going back and forth between 3 and 5, 3 and 5. Monotonic has to always be doing one or the other. Based on how it is written here, these formulas, it is allowed to be equal. Two consecutive terms can be equal. So a sub 1 and a sub 2 can be equal, but then it has to continue either going up forever or going down forever. If they're all equal, then it's not going up or down, so then that wouldn't work. But two independent consecutive terms can be equal. This one is not monotonic. This one, though, we already saw a little bit of that one on the previous page. It started off as 3 halves, then 2, then 9 fourths, then 12 fifths. Then it's going on forever. Is this one always going up or always going down, or neither? Well, 3 halves, that's 1.5. Then that's 2. Well, 9 fourths is just more than 8. I mean, it's 1/4 more than 8 fourths, which is 2. So, and then 12 fifths, that's going to be more than 9 fourths. This one is going to be going up forever. It starts at 3 halves, which is 1.5. Then it continues up forever. It never goes past 3, which we saw on the problem above, but it is increasing forever between 3 halves and 3. So this one is monotonic increasing. And then this one on the is not monotonic. This one, it's going to go up first and then go back down again, because just between 1 and 2. So it's going to go up and back down, so not. And then 2 last terms. Well, what it means for a term to be bounded. So a sequence is bounded from above if there is some number, they're calling it a capital M, that's greater than every single term. So if it is increasing forever and convergent, then it would be bounded above. I mean, it doesn't have to be increasing forever in that regard. But if it's bounded above and there's some number that's greater than everything else, then that would be mean that there is some upper limit. And then sequences could also be bounded from below, which means that there's some number n that's smaller than every single term, meaning there is some lower limit. So a sequence, if a sequence is both, this is very important. Let's circle the last line in this box. Very important, circle the last line. If it is both bounded and monotonic, it will converge. If the sequence is both bounded and monotonic, it will converge. So this one on A, it is bounded above at that horizontal line. It is consistently increasing in what they have shown us here, meaning it is monotonic increasing. What we see right here, if something's bounded and monotonic, it will converge. And we see here, this one is going to end up converging to whatever that horizontal asymptote is. So they're asking us here if it's monotonic, bounded, and convergent, and just say which one it is. This one is all 3. On this one, there is an upper limit. It's not going higher than this value here. So it is bounded, but it's not always decreasing or always increasing, so it's not monotonic. But as we go off this way to the right to infinity, it is going to approach 0, so it is convergent. And then on C, we see that it is always increasing, so monotonic. Monotonic. And it is bounded below at the x-axis 0, so bounded below. And then D has none of those. It's just going back and forth, smaller, bigger forever. Okay, so video of this will be posted to the calendar. There's more info about these lessons on Khan Academy. So we're going to learn this last unit that we have to learn through these Zoom lesson videos and through watching Khan Academy. The most recent questions you just asked, if it's bounded, does that mean there's a limit? Not necessarily. As we see on my 7A, it was bounded, but there was a limit. But then in 7B, it was bounded above, but there wasn't a limit there, but it was also bounded below, and it had a limit there. So it's not guaranteed to be, but if it is both bounded and always increasing, or bounded and always decreasing, it would have a limit and converge.
But it doesn't have to be monotonic to converge, right?
It does not. But if it is both monotonic and bounded, it automatically converges. But we saw in my example B, it increased at first and then decreased forever. And because it increased at first and then decreased forever, so let me go back and show you what I mean in this. In this one right here, it increased at first and then decreased forever, so it wasn't monotonic. It wasn't and decreasing. But it is converging to 0 later on. And then this one is on C. C is bounded below, but not above. So it has to be bounded in the same place. So like it's increasing. It's like since this one's monotonic increasing, for it to converge, it would have to have an upper limit, but it doesn't have an upper limit. It has a lower limit. But usually we can see by the formula or the graph what is happening out of those terms. The only thing that is guaranteed is that if it is both monotonic, if it's monotonic increasing and bounded above, it would converge, or if it is monotonic decreasing and bounded below, it would converge.
Oh, okay.
Okay. Any other questions before we end this? This has been a while, almost an hour long now. Friday's lesson will be on sections 17 and 18. Dan,
Real quick, on 7A, how do we see that that's bounded below?
So on 7A, it is technically bounded in both directions, above and below, and that is possible. There is a lower limit because none of those terms, for something to be bounded, all that means something's bounded below if there's just some number that's smaller than every term in the sequence. And on 7A, 0, the y value of 0 is smaller than every term in the sequence. This one is also bounded above, because bounded above just means that there's some number that's greater than every term in the sequence. And so that y value of 9 is greater than every term in the sequence. So this one, 7A, is bounded both above and below. Since it's bounded above and monotonic increasing, it will converge to that upper bound.
Okay, so it doesn't have to be a point that it gives. It can just be any value on that graph.
Yeah, yeah.
Okay.
Any other questions? Logan Martinez asked if it always starts at n equals 1. Yes, unless told otherwise. And yes, Kennedy, I will post the key to the homework section later today. But yeah, unless they tell you what n will start at, n will start at 1. So the keys to each sections, I'll start posting later today. So you could go ahead if you want to. Any other questions before we end? It's now 2:30. Yeah, well, it's good to see you. I hope that y'all are just happy and healthy and still enjoying yourselves. Don't stress out too much in this time. This time sucks. I get that. This is weird. But we'll make the best of what is currently being forced upon us. I hope you all have a great rest of your day, and feel free to leave this meeting now.
Bye-bye.
Bye.
Here, real quick, are we gonna do this like every day? Do you want each part of the lesson, or is it like day by day?
On Friday, I'm going to do sections 17 and 18. And in future lessons, I won't have to, like this whole beginning time, I went over just some main ideas of like what the next few weeks will look like and AP changes. That won't be necessary in future lessons, which will allow me to do multiple sections as
Okay.
well. In future lessons, I'm also going to give a time either at the beginning or end for you just to talk to each other or to me or just kind of
Okay.
hang out. Y'all aren't getting to see each other, which sucks. That's one cool thing about high school.
I know
when
it's
you're
kind of
senior.
weird, but
Yeah.
it's historic. So I mean, I'm happy to be a part of it.
Okay.
Something I'll remember.
Yeah, that is definitely true.
Okay, so I guess it'll just say on the calendar then, like days that it'll be scheduled to have a Zoom meeting or something like that.
Yeah, so I already changed the calendar a little bit from really even this morning, and I'll post the link to the Zoom on that day in the calendar, as well as also send it out on Remind. I'm gonna, and Jessica asked about making a Google Classroom. I don't want to give y'all the code to that until I have a bunch of stuff ready. There's no point in giving you the code until there's
Yeah.
stuff even there. So I will work on that. But for now, just
Yeah.
the link to the lessons will be on Google Class. I mean, on the calendar, and
Okay.
the other links that I think could be helpful will be there. But also, don't work on this or your other classes more than you normally would. You have
And
more
I'm
time
trying
than
not to.
you have more time than you normally would, but still be a kid.
I
So,
know. Well, it's like economics is we're having to learn like half the entire class basically on our own and with physics
Yeah.
and doing other stuff.
but your eco teacher should tell you that there are some sections, like in calculus, that they will not be testing.
Yeah, yeah.
But there's still probably some stuff that like here that you do still have to learn
Mhm.
probably on your own. Which
Yeah.
okay.
But
well,
yeah, this time was fine. I think I can work with that. That's the main thing I was wondering. Like any days are usually fine, but this time would work for me. I didn't know if that was something that we were gonna have to look at, or some people
well,
not.
and I
being
wasn't
able-
going to do it every single day either. As
Yeah.
I already said, it's only going to be Monday, Wednesday, Friday at 1:30.
Okay.
Okay.
Sounds good.
Okay. So see you same time Friday.
All right. See ya.